So we did ionic compounds. What about the covalent compounds? Covalent compounds happen when we've got nonmetals bonding with each other. We get a molecular compound. So here we have electrons being shared. Nonmetals would like to gain electrons, but if you're going to have a compound between nitrogen and oxygen, they're both asking the other to give them an electron, and neither of them is willing to do that. So they're going to share instead. So let's look at hydrogen and oxygen. So hydrogen has how many valence electrons? 1. It only has 1 electron. How many valence electrons does oxygen have? 6. So how can these two cooperate and get 8 valence electrons? Hydrogen only wants 2 because he's too small. Oxygen says, hey, give me that electron. And hydrogen's like, no way, then I won't have any. You give me one of your electrons. And oxygen's not willing to do that. So they decide to share. So if oxygen and hydrogen each share an electron with each other, that forms a bond between them because we're sharing electrons together. When you have something that's shared with another person, it's yours and it's theirs, right? My husband and I have 6 children. They're my children. They are also his children. So they kind of count twice, right? So these shared electrons count for hydrogen and for oxygen. So hydrogen now looks at this situation and says, I've got 2 electrons. I'm good. I'm happy. That's duet rule. I've got 2. I'm good. The oxygen looks at the situation and says, I've got 2, 4, 6, 7. This is better, but I don't have 8. So oxygen's going to look for another hydrogen. It's like, well, that worked out with the first hydrogen. We were able to share. So this hydrogen is willing to share an electron with oxygen. This hydrogen counts both of the shared electrons as his own. And oxygen counts the shared electrons as belonging to her. So 2, 4, 6, 8. So now they've achieved an octet for oxygen, duets for the hydrogen, without anybody gaining or losing electrons. They're just sharing. And that is a Lewis structure for a water molecule. We have bonding pairs and lone pairs or non-bonding pairs. So I'm going to draw that structure again. So this is a Lewis structure for water. We typically draw the shared electrons as a line. When you're first beginning, it may be helpful to put dots at the end of the line to remind yourself those are 2 electrons being shared. So that's 2 electrons, and this other one is 2 electrons. Electrons that are being shared are bonding pairs. So bonding pairs would be that guy and this one. And lone pairs are ones that are not being shared. They're alone. So lone pairs, they're not bonding. That's those guys. So there's bonding pairs and lone pairs. And identifying lone pairs is important. It'll come in handy later. Any questions? So Lewis theory explains why halogens form diatomic molecules. So we learned about the 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Why do they form diatomic molecules? Well, let's look at bromine. So if we have 2 bromine atoms, how many valence electrons do bromine atoms have? 7, because they're in group 7. Okay, so they're each trying to get an electron so they can have 8. This bromine's like, give me an electron. This one's like, no, give me one of your electrons. They can't agree, so they decide to share instead. If they share an electron with each other, the shared electrons count for both. So this bromine then has 2, 4, 6, 8. This bromine has 2, 4, 6, 8. They both have octets. Bromine is more stable when it forms Br2 molecules. And that happens for all of the halogens, fluorine and chlorine and iodine. We know that hydrogen is also a diatomic element. So here's 2 hydrogen atoms. They each have 1 electron. Hydrogen's trying to get 2 electrons. So 2 hydrogen atoms can help each other out by sharing an electron with each other and forming a diatomic molecule. Any questions? So that's sharing 1 pair of electrons. You can share more than 1 pair of electrons. So let's look at oxygen. Oxygen is also a diatomic element. Oxygen has 6 valence electrons. So if 2 oxygen atoms get together and decide to share an electron with each other, does that give them an octet? Not quite. Now they've got 7. So what do? Well, let's do more sharing. So let's share another electron. So these shared electrons count for both. So there's 2, 4, 6, 8. 2, 4, 6, 8. Now they both have octets. That's kind of a wonky drawing. We would typically do it like this. How many lone pairs are in this structure? Here's 1 lone pair and 2. So this oxygen has 2 lone pairs, and this oxygen has 2 lone pairs. So there's a total of 4 lone pairs in the whole thing. And how many bonding pairs? 2. So this is 2 pairs of shared electrons. That's called a double bond. A single bond is a single pair of shared electrons. A double bond is 2 pairs of electrons being shared. And so we usually represent that with a double line. You can also think of it, or draw it if you wish, with dots at the ends to help remind yourself that there's 2 electrons in that line. So double bond, 2 electron pairs being shared. The double bond is a tighter bond, a stronger bond than a single. And so the bond is shorter. The distance in an oxygen-oxygen double bond between the 2 atoms is 121 picometers. If you have a single bond, it's 148 picometers. So by sharing more, they come closer together. Let's look at nitrogen. Oops. How many valence electrons does nitrogen have? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm drawing them in the particular way that I am because I know what I'm going to do with them. So how can 2 nitrogen atoms cooperate and achieve octets? Well, look at those unpaired electrons. So this is a pair of electrons, and these are unpaired. The unpaired ones are the ones that are probably going to get shared. So take this unpaired one and share with that unpaired. And let's share these and share those. So this nitrogen counts its lone pair here, 2, 4, 6, 8. This nitrogen, 2, 4, 6, 8. They have to share 3 pairs of electrons in order to get an octet. And so we would normally draw that as 3 lines, and then the lone pairs. So that's a Lewis structure for a nitrogen molecule. It's a triple bond. Triple bonds are even shorter and stronger than double bonds. The nitrogen-nitrogen triple bond distance is 110 picometers. If you have a double bond, it's 124. So the more pairs of electrons that are being shared, the closer those atoms get together, and the harder it is to tear them apart. So nitrogen is a diatomic element, N2, and it's very stable because it has that triple bond. Nitrogen is the main component of air, and it doesn't really react with much of anything.